Hi, everybody. Welcome to our first little mini lecture. At this point, you should have watched the YouTube playlist. So if you have not done that, stop here because the goal of these mini lectures is to tie up some loose ends and connect the dots for you. Um, so I won't be going into, I feel like, as much of the general details as those YouTubes will be. Okay, so let's get started on our first one. We're going to talk about weather versus climate. So how do we define the weather? On the on the left is a graphic from the UN Development Program, and you'll recognize a lot of these terms because they're the ones we see in a standard weather forecast. On the right is an image from, I believe, this was the record-breaking Christmas this year in December. So these are station plots, and basically they're a graphical representation of the weather elements that we see on the left hand side. And it's basically what you would see when you open up your standard weather app, right? You're going to see temperature, wind, speed, direction, possibly dew point, and then you're going to see whether it's raining, different weather types, cloud cover, station pressure. So everything on the left, or I'm sorry, on the left, right, is graphically represented here on the right. And I'm pretty sure you'll be able to see my pointer on this, but this right here is Denver. It's showing a high of what I believe is 69. It's real small on my screen. But the winds are coming out of the north, and this is down here, Centennial. This one's up here, Broomfield. And I don't need you to know how to read these very well. I'm just trying to give you an idea of where we are. Now, all these weather phenomena can be studied in terms of climate too. So, what makes them different? That would be the time scale. So, weather is answering the question, what's happening today, tomorrow, or next week? Like, how much rain is falling? We have a rain gauge here on the left, and we have the question sometimes is, how windy is it this afternoon? And we have the anemometer, which measures wind speed and direction on the right. And then we also have weather models that we can use to forecast future weather. And that's the example of that is here in the center, where we have a predicted temperature in the middle of the US. And I think this is from a couple weeks ago. But the other thing is, we can also use weather models or predictive models to forecast weather on different time scales, including month, like on the left, or seasonal time periods. In these maps from the Climate Prediction Center, which is an arm of the National Weather Service, these maps are showing forecast chances for above or below normal precipitation, and then temperature as well, but that's not what we have plotted here. Oops, sorry about that. In these in particular, it looks like northeastern Colorado has equal chances of being both either above or below normal precipitation for the next month. This is January, and then for the rest of winter. So, weather is both the type of phenomena that we see in the atmosphere happens in short time periods, right? So today, tomorrow, next week, and even stretching out to a month or seasonal prediction. Okay. So if weather is happening then at the short term, then that means climate is happening in the long term. And our example here is a graphical representation of generalized climate zones across the globe. We have tropical, or hot and humid near the equator, then hot and dry in yellow, in between 20 to 30 degrees north in latitude. Let me see if I can put my pointer here. So we have from about here to here is the dry zone, which is going to be hot and dry. And then in the green, we have temperate zone, which is a warm and humid. And that's going to be right here. And then we have the, I guess, purple zone, which is continental. And then that's going to be cooler and dry. And then the very last one is polar, which is going to be very cold and very dry. And so in general, as we go from the equator, we have very little heat and we have very little heat. We have lots of heat and lots of moisture at the equator, and then we have very little heat and very little moisture at the poles, right? So we're starting here at the equator. Tropical is hot and humid. Poles are very cold, very dry. So in general, we're kind of breaking between two extremes here, the equator and the poles. And so somewhere in the middle is where we should be. And Denver sits at about 39 degrees north, which would put us smack dab in the middle of the temperate zone. But there's a lot of other cities in this zone, like Philadelphia. And Philadelphia's weather is quite different from Denver. So let's take a closer look at that. Here we have two graphs showing climate normals, which are just the averages of the max, mean, and minimum temperatures. So we have the max in red, the average, right? The normal average or average mean, however you want to say that. It's kind of complicated, but basically this is the average between these two lines. And then the blue is the normal for the minimum temperatures. And then in the green bars, we have precipitation, and that's going to be general precipitation. So that includes all types, which is snow, ice, and rain. Okay, and then the other thing you have to mention too is the scales. So unfortunately, I don't have control over these scales when they plot, but the left-hand side is going to be the scale for the precipitation, and the right-hand side is going to be for temperature. And if you look across the two graphs, they're also not at the same scale, so you can't necessarily compare these directly, but I'm going to pull out some figures so that we can talk about it a little bit. Okay. And then on the bottom here, we're going across the whole year, January to December. And so these are each month, January, February, March. Okay. When we look at these two graphs, it's easy to see some differences. Like an obvious one is precipitation, because Denver's wettest month over here in May gets about 2.25 inches of precipitation. But in Philly, their driest month, which is actually looks like February, but could closely be November. February, they get about, in their driest month, 2.6 inches. So that's quite a difference. And we can definitely say then Denver is much drier than Philly. And looking at their temperatures, even though the scales are different, they're also, they have the same pattern because they're in the northern hemisphere. Low temperatures in the winter, high temperatures in the summer. But especially the minimum temperatures are quite different for both of them. Denver sees a much lower minimum temperature across the whole year, and you can see that. Let's see here. Especially in the summertime, our average minimum temperature in the summer is going to be 59, whereas in Philadelphia, it's going to be closer to 65-ish. So it's pretty different. So take a moment to absorb this, okay? We know that the global climate zones change with latitude, but both of these cities are in the temperate zone and along the same latitude, and there's a pretty significant difference. It's interesting, and this must mean there's something more to climate than just latitude. And here's another example of this. This time from Boulder, which is on the left, in Peoria, Illinois, which is actually where I live, on the right. These two graphs look much more similar in pattern than the last one. Or springtime precipitation maxes are pretty similar. But again, Peoria sees much more precipitation, And I would say, what are we doing? Like a little over 3 inches here, even though the maxes are in the same months. The maxes in Peoria are higher, over 4 inches, 4.6, let's say, and 3 point, I don't know, let's call that 2.5. So over an inch difference. So it's definitely wetter in Peoria. And then also, paradoxically, Boulder sees lower minimum temperatures and higher maximum temperatures in the winter, while Peoria sees lower max temperatures and higher minimum temperatures in the summer. So at this point, you're probably thinking, great, my head is spinning. And that's good because that was what I was trying to get you to do. Not purposely trying to confuse you, but I am trying to get you to think. My point in telling you all this is to drive home the point that climate is both general and specific. We can look at climate over, although all climate is in the long term, we can look at climate over large distances like the globe, but we can also look at it over small distances like here in the US. So even though at the global scale, Boulder, Denver, Peoria, and Philadelphia are all in the same temperate zone, when we zoom in, we can actually see that each city is in a different zone locally. So Denver and Boulder are somewhere around here, right? I don't know, somewhere in here. Okay, and this is in zone B, which is a dry climate, and Philly, which is over here-ish. I can't remember where Philly is. I should know this. This is where my family lives, but I don't know, somewhere over here. And then Peoria is like about right here. And both of these are in zone C, which is a subtropical climate zone. And other zones which are on this map are also interesting. And I'm not really expecting you to memorize these, but just understand conceptually, where they are. Zone A would be tropical, and the only place on this map that is tropical is going to be the very southern tip of Florida. And then let's see, we did B and C, so zone D, which is the continental, and that's going to be a lot of the very far north United States, the contiguous US here, but also some of the foothills and mountains are also considered the continental zone. And then H, which is the highlands, and this is, you're going to see, you can't really see, it's very fine scale, it might be hard to see, but there's some here in California mountains, you got some here in the Rocky Mountains, all the way up here too in Wyoming. So highlands are where the climate changes drastically over a short distance due to changes in elevation, right? So we can look at the climate here in the US, broken down into these smaller zones. And then we can also look at the globe again in these smaller zones. And when we look at the whole world here and compare it to that depiction of the global zones that I had you look at, in the beginning of this little lecture, this is much more detailed. And essentially what I want you to understand is this is why this is interesting, right? The climate is something that we can look at such different scales, and we can also use that information, that even though we have the big global scale and we can use that information to inform our decisions, we also use these finer scale climate zones to help inform our decision making, but also our knowledge of weather. So basically, even though weather and climate are different, they're both intertwined as well. Okay? All right, so that's where we're going to end this one, and I'll see you in the next lecture.